Okay, we're beginning the course today with this video. Uh, we're going to talk about monitoring the weather and just what weather is. Just start with the basics, very simple stuff. So let's see what we've got. So what are some of the basic characteristics of the atmosphere? What's weather? If you walked outside, how would you describe your day-to-day weather-wise? Did you have a nice sunny day? Was it pleasant out there? No, maybe it wasn't oppressive. It really felt hot and humid. Or was it really, really cold and you were shivering all day because you couldn't get warm? Did you have a lot of clouds outside? Or was there precipitation? I mean, was it snowing? Was it raining? Oh, yeah, did you get blown over by the wind? Was it really, really strong? And where was it coming from? Maybe that's kind of important to you. Maybe you want to know, especially if you had a little fire you were building and wanted to keep it away from the trees or whatever, trying to burn out some brush. Maybe you cared about which direction that wind might blow. So the study of meteorology is just a study of the atmosphere and the processes that cause all these things we just talked about quickly. Climate is looking at these in the long term. It can be an average over 30 years. It can be averages over thousands of years. We're interested in climate because of climatology is the study of climate itself. What actually controls climate? And climate is weather occurs within climate. So each one of these kind of encompasses the other. Climatology being over everything, climate being within climatology, and weather being within climate. There are tons of ways to access the weather information now. You can get it from NOAA Weather Radio, but I bet none of you do. Weather apps are all over the place, television, smartphones, all kind of ways. All right, all this weather talk. Weather, that's the definition of weather. Let's start with that. Weather is what's happening now. So in other words, the moment you walked outside, what did you sense? Not waiting 10 minutes and then what did you feel? That would be a whole different weather. Weather is what is happening at the exact moment in time. That's why all measurements, when I want to define weather around the globe, are taken at the same time within a matter of a minute or two. So, for example, if I want to know what the weather is at 7 a.m. Eastern Standard Time in the eastern United States, but I also want to know what it is in the central, in the mountain, in the west, and all the way out to California, all this has to be at exactly the same time. So we use Universal Time, Zulu Time, Greenwich Mean Time. So at 12Z or noon, then that is the equivalent of 7 a.m. Eastern, 4 a.m. Pacific. But they're all exactly the same time as far as having the same time over the globe. So every one of those observations would constitute the weather at 12Z. If I wanted to know it at 6Z, just be a different set of times. And we take observations hourly, literally. So every hour is a new set of observations. There are different types of pressure systems. Notice I said pressure systems. I'm not talking about weather systems necessarily. They are part of weather, but there are different types of pressure systems. There are high pressure and there are low pressures. Low pressure generally brings bad weather. High pressure generally brings good weather. The winds rotate around these. High pressure has typically clockwise rotation and sinking air in the northern hemisphere. They generally track towards the east and southeast. Low pressure may move up from the south to the north or south to the east. And weather on one side of it is very different than the weather on one other side of it. For example, as the low is moving by your area, if you're on the west side of the low, it may be cold and pouring down the rain. On the east side of the low, it may be relatively warm and maybe some thunderstorms. So they're very different weather. But notice, a low typically does bring bad weather with it, and the winds are counterclockwise. So if that means once the low went by you, the winds would shift to the northwest. And here you can see them. And the winds are coming into the low. And you're going to get a question this week about that. For example, if this low was sitting over Cleveland and you lived in Columbus, Ohio, what direction would you think the winds would be? Because, hey, Columbus would be down to the southwest of the low now. Well, the winds would probably be coming in from the northwest or north. somewhat in towards the center of the low. On that side of the low is going to be the cold air, because what's to your north? Canada. So that's where the cold air is going to be coming in from. Air masses, on the other hand, are big masses of quantities of air. They cover thousands of kilometers or miles, and they all have a uniform characteristics. Typically, they're pretty close to the same temperature, pretty close to the same humidity. So guess what? If you're up in Canada and your air is sitting in Canada for a while, it's going to get cold. It's going to be pretty dry because there's not a lot of moisture there. Hi. But if that same, take a different air mass, now you have a quantity of air. We'll say it's sitting down over the Gulf of Mexico into the Caribbean Ocean. Well, you got a lot of warmth down there, right? So it's going to get warm. Oh yeah, and a lot of water. So it's going to be a very warm, humid air mass. And these contrasted air masses, they're kind of defining by fronts. And they slope. In other words, the atmosphere is three-dimensional. So warm air is lighter than cold air. So warm air is going to tend to rise up over cold air. So a cold front is going to be pretty sharp, going to typically have showers and thunderstorms with it, cumulus clouds. Warm fronts, a lot more stratus type clouds moving along it. Maybe you'll see cirrus at first, then some high cloud, altostratus, and eventually down to stratus and nimbostratus and even rain. So there's a different progression of clouds as you're going along here. And warm fronts, they can keep precipitation going for hours, maybe even a whole day or more. Cold fronts, on the other hand, as they're moving through, typically only have a narrow band and may only last for a few minutes to maybe just a few hours. But they can be very, very heavy and intense. Wind directions will shift on each side of the front as well. And some fronts don't have any clouds or precipitation associated with them, just a slight change in temperature or humidity. And fronts are all anchored to lows on the weather map. Coastal areas have sea breezes. If you go up to Lake Erie in the springtime, I will guarantee you a lot of days there's wind coming off the lake that as closer you got to the lake, it got cooler and cooler. While as you went away from the lake, it got warmer. We get the same thing here in southeastern Virginia. I get it off the ocean. So that's a coastal sea breeze. There's lake effect snow that occurs in the Great Lakes. And yes, it occurs in the eastern part of Ohio. It can occur in the western part, coming off of Lake Huron and down. A lot more tornadoes in the central United States. Thunderstorms, very frequent down the southern part of the United States. Tropical systems might impact and will impact, like Ida may do, the southern part in the Atlantic. But if you're defining the state of the weather, you want to know the temperature. You want to know what the max temperature is. Max temperature is going to typically be in the late afternoon, mid-afternoon probably. The maximum heating of the atmosphere actually occurs around noontime, but it continues heating. It's like if you turned on a stove and you got to reach its maximum temperature, that pot of water starts heating up. But you turn the temperature back just a little bit, that pot of water is still heating. So it reaches its max temperature eventually and later until you turn the heat off. So that's what happens with the atmosphere. As long as the sun's out, it's getting hotter. At nighttime, sun's not out, it's getting colder. Dew point is just a measure of humidity in the atmosphere. Relative humidity is how wet the atmosphere actually is. When we talk about air pressure rising and falling, low pressure, air pressure is going to fall as it's approaching. High pressure, air pressure will begin to rise. So as a cyclone, which is low pressure, approaches, pressure is going to drop. We can look at sky cover. I like to watch the clouds personally. Weather Service issues different watches and warnings that you're going to learn a little bit about here. And here's just sky watching, looking at cirrus clouds. And here you have stratus or cumulus clouds down here. A little bit more bubbly. Oh yeah, they look a lot darker than the cirrus clouds, don't they? Well, why is that? Well, the cirrus clouds are pretty high in the atmosphere and they're ice. These cumulus clouds are fairly low and they're water. Water looks darker than ice. Fog is another type of a cloud. It's just a cloud in contact with the ground. So stratus clouds form in layers, and We've talked about it, and we're going to talk about it throughout the whole course. It's three-dimensional, the atmosphere. So winds move in different directions in different parts of that atmosphere. So it can move the winds can move clouds in different directions in different layers. Cumuliform, just puffy clouds. Cumulonimbus clouds are basically cumulus clouds that emerge together and keep going up, making a thunderstorm. So with that, I just wanted to show you a couple little things on the weather map here today. This is a surface weather map. So here's high pressure over northeastern Canada, Hudson Bay area. And here is a week's low pressure out over Iowa, coming into Iowa right now. There's another low north of Montana. Oh yeah, air masses. Well, south of this front, temperatures are well up in the 80s, and dew points are in the 70s. I want to give you a chance to get a little bit of an idea here on reading a station model. So that's why I kind of zoomed in here a little bit. This pick here, for example, this one, I think this might be Mansfield. I am not 100% sure. That might be Mansfield there. But temperature is the upper left-hand corner. What this represents is the observation at this exact where the circle is. Circle has nothing collared in. That means there's no clouds. If you see this one over here in Indiana that's completely colored in, it means it's cloudy. Temperatures off to the left-hand side, 83. Dew point down to the lower left, 69. So that is the actual temperature. That's the amount of moisture in the air. So the higher that number is, the more moisture is in the air. Here is the pressure, something we're going to learn a lot about here soon. And this is 2005, which actually translates, pressure is measured in millibars as far as meteorologists are concerned. You probably get it in inches of mercury, but that is 1020.5 millibars. How did I know that was 10 in front of it? If it's less than 500, it's probably going to have a 10 in front of it. If it's more than 500, it's probably going to have a 9 in front of it. So that a more intense low would be like 979.9 millibars or 979 millibars. You will be drawing this week isobars like this. So all you're trying to do is keep higher pressure on one side, lower pressure on the other side. That represents that isobar. And if you did it right, they should match up really well to the map you're getting. And you'll see that they are also divisible by 4, which means that when I'm looking at a pressure thing, for example, of 1020, if I can divide 20 by 4, I know that's one of the pressure levels I'm going to use. Maybe another one might be 1024. Maybe another one be 1016. So those are going to be pressure levels that I'm going to be analyzing for. Here's the National Weather Service radar for up in Cleveland's right now. Not a lot going on. Actually, this is Buffalo, it says, but still not much. A few showers across the northern part of Pennsylvania, southern here, and some nice little thunderstorm coming across here at this time. I wanted to show you a satellite image, and I wanted to show it of a storm. Here is Ida. This is a hurricane that's moving across into the southern part of Cuba, extreme western Cuba right now. This is an infrared satellite. You can see the cold cloud tops. They're actually warming a little bit as it's coming towards land. Interaction with land is not good for hurricane, but pretty cold. So that is the thunderstorms with Ida right now. And finally, just looking at our visible image right now, you can see cumulus clouds. They kind of form like dots. They look like little bubbles on satellite. And they're very reflective because water, ice, the top of cumulus clouds are very reflective. So you can see thunderstorms popping up down here in the Maryland, Northern Virginia area. You can see the thunderstorms coming across the Great Lakes, and we looked at that radar, and you can see the thunderstorms here. So hope it give you an example of what you're going to be talking about this course. And please don't hesitate to ask me if you have any questions.